question, fx equal to mod x plus mod x minus 1 is differentiable at x equal to 1 and x equal to 0. Is it differentiable or not? That's the point. So first you have to reframe this function, that is fx is equal to x minus x plus 1 for x less than 0. For x greater than equal to 0 and less than 1, it will be x minus x plus 1, and it will be for x greater than equal to 1, it will be x plus x minus 1. That means this will become, fx will become minus 2x plus 1 for x less than 0, for greater than equal to 0 and less than 1. This x and this x will cancel, it will become 1. And for this, it will be 2x minus 1 for x greater than equal to 1. And the graph of this function is, now you see, this is your 0 point, this is your 1. At 0 and in between 1, suppose this is 1. So it will be like this. Now at put here minus 1. If you put minus 1, it will become 3. So at minus 1, it will be somewhere here. And put 2, 4, and this is 3. If you put put here 2, where 2 is greater than 1, as 2 is greater than 1, so 4 minus 1, that is 3. So at 2 it is somewhere at 3. The graph of this function is something like this. It will go like this. The graph of this function will go like this. So now we will check the differentiability at 0. So f dash 0 plus, this is limit h tending to 0, f 0 plus h minus f of 0 upon h. This is equal to limit h tending to 0, f0 plus h is, at that point it is 1 only, fh minus f of 0 upon h. Now at f0 it is 1, and at h between just greater than 0 it will be 1. So 1 minus 1 upon 1, it is 0. Now at the left hand derivative, we will check the left hand derivative. The left hand derivative, f dash 0 minus, would be limit h tending to 0, f 0 minus h minus f of 0 upon minus h. So this is, we will have to take this function. We will have to take this function. So you have limit h tending to 0 minus, let us, this is 0, 0 plus. You have f minus h minus f of 0 upon minus h. So now you will have to take here, this will become limit h tending to, just a minute, limit h tending to 0 minus f of, that is minus 2 of minus h plus 1 minus 1 upon minus h. So this becomes 2h plus 1 minus 1 upon minus h, limit h tending to 0 minus, and this comes out to be, this 1 and 1 cancels out, this h and h cancels out, this comes out to be minus 2. So the left hand derivative is not equal to right hand derivative. So f is not differentiable, just a minute, not differentiable at x equal to 0. Similarly, for, we will check for x equal to 1. Now f dash 1 plus is equal to limit h tending to 0 plus 1 plus h minus f of 1 upon h. So 1 plus h, we know this is the function. You can check 2x minus 1 is the function. So at 1 and at 1 you will have to take this. See, at this is 2 1 plus h minus 1 upon h, limit h tending to 0 plus. right side of 0. So this will become limit h tending to 0 plus 2 plus 2h minus 2 upon h. This 2 and 2 cancels out. This h and h later on cancels out. So this becomes limit h tending to 0 plus 2h upon h. They cancel out, you get 2. Now we will check the left hand derivative. F dash 1 minus. That means on the left side, limit h tending to 0 minus f1 minus h minus f of 1 upon minus h. See, at 1 minus h at less than 0, less than 1, sorry. At less than 1, you will have, the value will be always 1. And at f1, if you put f1, it will become 2 into 1 minus 1, that is again 1. At f1, that is at x equal to 1, you put here 1, you put here 1, and then 2 into 1 minus 1 becomes 1. So this is 1 limit h tending to 0 minus f, this is now 1 minus 1 upon minus h, and this is 0. So the left hand derivative at 1 is not equal to the right hand derivative at 1 plus. So f is not differentiable at x equal to 1. Now a different sort of a function I will now show you. Wait. Suppose this is another question. This is the question. Fx is minimum of x comma x minus 1 mod. Now what you do is that in this case you need to do this thing. This is at mod x. I've already told you this function will be something like this. Let's draw it like this. Okay, and at x equal to 1, this is at x equal to 0 for this function. This is for this mod x function. Now for this, at x equal to 1, we will have this 1 here. This will go like this. This will go like this. Now this will give you a resultant function like this. This will give you a resultant function like this. See, this will give you like this. You will have this, you will have this, and then you will have this. So 0 and 1, and this point is somewhere is half, always. This is the midpoint. So it is this function. This function is this total function, minimum. Keep this thing in your mind. This function is not differentiable at 0, x equal to 0, half, and 1. This is one important example. Now this function would look like fx equal to minus x for x less than 0. That means this part. Now for x, it will be x for x greater than equal to 0 but less than half. That means this much part. This is minus x. This is minus x, right? And this will be minus x minus 1 for this function for half greater than equal to half but less than 1. That means this part of the function, that is this is minus x minus 1, and the last part, that is x minus 1 for x greater than equal to 1. That means this one part, x minus 1.